Okay, what we're going to do, we're going to have a look at sketching a function. So here we've got the function being a quadratic polynomial. So we've got y equals x squared minus 3x minus 4, and we need to sketch it. Now, to sketch it effectively, we need to identify our y-intercept, our x-intercept, and a turning point. Now, to find our y-intercept, we let x equals 0. To find our x-intercept, we let y, or the equation, equals 0. I always found that really confusing, so we're letting the equation equals 0. And then the turning point, we're completing the square, or we're finding the point, the x value, halfway between the two x-intercepts. Parabola being symmetrical, halfway between the intercepts will be our x value for our turning point. So first thing we're going to do is look at the y-intercept. So we let x equal 0. So as a result, we'll have 0 squared minus 3 times 0 minus 4, and we end up with negative 4. So therefore, we have a y-intercept at 0 and negative 4. Really easy thing to remember is that thing there is always your y-intercept. Now your x-intercepts, looking at this, I'm going to try to factorise it. I'm going to try and find two factors of negative 4 that add up to make 3. I know factors of negative 4 are going to be negative 2 and 2, negative 3 and negative 4 and 1, or negative 1 and 4. So I'm looking at those now. I know nothing 2 will add up to negative 3, so I'm thinking the 1s and the 4. Now it's got to be negative 3, so negative is got to be that, and we would have positive. Negative 1 times, positive 1 times negative 4 gives us negative 4. Positive 1 minus 4 gives us negative 3. So that's what we've got there. So we're saying let y equal 0. So we're saying x squared minus 3x minus 4 equals 0. So the whole equation equals 0. And now, so here's our factors. Positive 1 and negative 4. So we've got x plus 1, x minus 4 equals 0. Now we've got to apply this little thing called the null factor law, which tells us a times b equals 0, then either a has to equal 0 or b has to equal 0, or both of them equal 0. So that's how we can do it. So for this part here to be equal to 0, x has got to equal negative 1, and for this part here to be 0, x has got to equal 4. So that's our two x-intercepts. So we've got x-intercepts at negative 1 and 0, and then 4 and 0. So from there, it's time to sketch. We can sketch with this information. So we go through, we sketch our parabola, where we're at negative 4, negative 1, and 4. Make sure you are putting these coordinate values here. Make sure you write them with coordinates. How they will. I just can't do it effectively here. Okay, so now we've got that, we can find our turning point. Now, our turning point is halfway between the two x-intercepts, so it's going to be there. That's going to be our x value for our turning point. So between, we're at negative 1, we're going to go to 4. We've got a distance there of 5. So if we're at negative 1, if it's 5 units between both of those, well then half of 5 is 2.5, so negative 1 plus 2.5, 2.5, we end up with 1.5, or 3 over 2. So that's our x value. So this is 3 over 2, and we've got to find a y value. To find a y value, we substitute this 3 over 2 into our equation. So I'm going to put up a little heading, hopefully I'll have enough room, for turning point. So first thing we're going to do, we've got an x value, so that's what we're going to substitute in. So we're going to have 3 over 2 all squared minus 3 times 3 over 2 minus 4. So 3 over 2 all squared is 9 over 4 minus 3 times 3 over 2 is 9 over 2 minus 4. Then we simplify it, write all as factors of 4. So all as a fraction out of 4. Now 4 as a whole number is 4 over 1. So we end up with 9 over 4 minus, we can convert this to 18 over 4. So we want the bottom one to be 4. So we double it. When we do the bottom, we've got to do the top. and now minus 16 over 4, and we're left with negative 25 over 4. So we have negative 25 over 4. So that's the way they should all be labelled. All these 3 points, but all 3 intercepts should be labelled with that. So now that we've got that, we'll try to complete the square. So we've got x squared minus 3x, and whatever the number is, we halve it and square it. So plus 3 over 2 squared minus 3 over 2 all squared minus 4. Factorise those 3 to x minus 3 over 2 all squared minus 3 over 2 all squared becomes 9 over 4 minus 4. So we've got x minus 3 over 2 all squared minus 9 over 4. And remember, this is 4 over 1. We want to write it as over 4 because we've got this. We've got to multiply them both by 4. So we get 16 over 4. So it ends up being x minus 3 over 2 all squared minus negative 9 take away 16 is negative 25 over 4. So it holds true. We've got a turning point at negative 3 over 2. Sorry, not negative 3 over 2, positive 3 over 2. And negative 25 over 4. So, to go over that again, we're sketching a function, got to identify the y-intercept, the x-intercept, and then a turning point. Y-intercept, we let x equal 0, solve, and like we said, it's generally that value there. And that's the same for any kind of graph you do. For the x-intercept, we let y equal 0, let our equation equal 0, factorise if you can, otherwise use quadratic formula, and it tells us coordinates of the 2 x-intercepts. From there, we can sketch both y-intercepts and an x-intercept. Turning point, halfway between these two. Distance of 5, that means we've got to go 2.5 units across. Negative 1 plus 2.5 gives us 1.5, or 3 over 2 as a fraction. Fractions are much easier to work with. From there, we substitute our x value into our equation, we solve, or we can complete the square to find the turning point in turning point form. But they're the steps that we take. Find these different things and sketch.